Hello people, this is Jasneet Singh aka Innovative Coder from Innovative Coder Workstation, and in the previous video we talked a basic intro about what are basically microprocessors and a little bit of very short intro of microprocessors. I told you about this diagram, which is the basic diagram of computer system, computer components, and today I want to talk about extending this introduction. Today I want to talk about more. Today I want to talk more about these processors, and we'll be starting with a basic instruction cycle. So generally, basically, this microprocessor and microcontroller subject comes in fifth semester of electronic students in engineering. If I talk about IP University, from which I belong, and there are various universities in which this subject is encountered by students. So my class fellows and my seniors have told me this thing that in complete engineering, this is the toughest subject you'll encounter. And I have no other playlist on my channel. I haven't made any videos of any other subject rather than this, but this, because this is not the toughest subject actually. If I tell you about this, I may not score well, I may not do well in this subject, but I like this subject very much. This is not the toughest subject, this is the most interesting subject of engineering. Mark my words, definitely. Because see, I'm a programmer, as you might have seen my other videos. I'm a programmer, I'm a machine learning engineer, but I love this subject. I am making videos on this subject, because what happens is, when you are doing programming, either suppose you do a equals to a plus b in C++. So what happens is, what you just write this, compile it, and the answer is you get the answer. But with microprocessors and microcontroller subject, I have learned what is the basic underlying concept of these things, and this is what I want you guys to also know, that what are these processors doing beneath them, and how is our code is compiled, and what all is actually done under the layers. Because the more you go deep into the layers of the computer system, the more you understand about what all is happening, and the more you understand about what all is happening, the more you are able to tweak the things, and this gives you flexibility, definitely. Okay, so coming back to what we were doing was, so we were starting with we were doing introduction to microprocessors, and I told you about what is the history behind microprocessors, and where are microprocessors used in real life. So we talked about traffic lights, we talked about remote controls, AC remote controls, TV remote controls. There can be tons and tons of examples of microprocessors. So 8085 we talked about, which was the first commercially successful microprocessor. Then came 8086, which revolutionized the world. It was the powerful microprocessor at that time, and because of a few concepts of pipelining and banking and like various other concepts which were involved in that system, so there were a few systems which made that thing very powerful. And this is how research is done actually. So you generate a very new concept, and then there are researchers who deep dive into that thing, and then something new is built. This is the same thing happens in machine learning as well. Basically, so keeping that thing aside, okay, so let's take our talk further. So what actually are microprocessors? So microprocessors are the heart of a computer system. Microprocessor are heart of the computer systems. So as the whole body is controlled by our heart, same thing is with microprocessors. Same thing is with computer systems. Computer systems are controlled by microprocessors. So current generation computers use processors like i3, i5, i7, and the latest news is of i9, Core i9, which Apple has recently put into its 4 lakh laptop, I think so. I've heard about it. Okay, fine. So we have come a long way from our first generation microprocessors, which were 8085, 8086, and further series of these microprocessors, which we'll be learning in further videos. So if today you go into market and ask for a laptop, for a decent laptop of ranging from 60,000 or 50,000, you'll find a CPU of a microprocessor of Intel i5, I think so. Or if you have a range of 80,000, you might encounter i7 as well. So this is how the research is done, and development is done. So 8085, 8086, then there were a huge range of processors, Pentium, then Intel cores, and then we have today Intel Core i9, or if you talk about AMD series, if you are aware of that. So back in the day, 1940s, I'm talking about 1940s, when the microelectronics was not even invented. So at that time, processors looked very different. Processors were very different. They were totally different, and were certainly not micro in size. If we talk about the size, then they were not micro, right? They were created using huge arrays of physical switches, which were operated manually and often occupied very large rooms. So they occupied very large rooms, right? In the following decades, as we progressed, as the generations came through, as we moved on, with the invention of microelectronics, scientists managed to embed thousands of microscopic switches, known as transistors. If you have heard about them, and if you have read about them, I hope so. I hope so. You would have done about you would have learned about transistors inside a small chip, and called it as a microprocessor, right? Okay. Over the years, microprocessors grew in strength. Okay, from housing a few thousand transistors like 8085 to containing more than a billion transistors, which is the Core i7 I'm talking about. The computational power has been increasing exponentially. The computational power has been increasing exponentially. Having said that, some of the basics still remain the same. So if we talk about 8085, the instruction cycle remains same in Core i7 as well, and in all the microprocessors. And if we talk about memory, then you can fetch only 1 byte of memory, even in today's processors as well. So these are the concepts which remain the same, and that is why this introduction video is very important. So if you have seen my earlier videos, or if you have seen my future videos, where I'll be talking about 8085 and 8086 processors, you must see this video, because you'll be understanding what is the introduction and why these microprocessors are necessary, and what are the basics of these microprocessors. So basics, clarity of basics is very important before jumping to very high concepts and very big concepts. Okay, fine. So to put it simply, the main function of microprocessor is to fetch, decode, and execute. This is the main function of a microprocessor. So if this is visible, so microprocessor, fetch, decode, and execute. Instructions are a part of program. Programs are stored in memory. Data and programs are stored in memory. Firstly, microprocessor fetches an instruction from the memory. It then decodes the instruction. First fetching is done, then it decodes the instruction, and then the execution is done. So decoding means it understands the binary pattern of the instruction. So what is a binary pattern? A binary pattern, also called as opcode, is a pattern of zeros and ones. So every instruction can be decoded into its binary pattern known as opcode, right? Okay. So every instruction, when stored in the memory, is in its unique binary form, which indicates the operation to be performed. This is called as its opcode. Fine. So upon decoding the opcode, microprocessor understands the operation to be performed and hence executes the instruction. So mark these words: opcode, execution, fetching, decoding, because these are the terms we'll be encountering a number of times in our further videos of 8085 and 8086. Fine. So the entire process, this entire process of fetching, decoding, and execution is known as instruction cycle. Now the process is repeated in the next instruction like this, one by one. All the instructions of a program are executed. Okay, of course. By advanced concepts like pipelining, multitasking, multiprocessing, etc., you can fasten this process, and this procedure become very advanced and efficient today, right? So you will get to learn all of them in the due course of time, in future videos maybe, because in 8086 we use this concept of pipelining, so you will be understanding about it. So be patient, be calm, we'll be learning these things, right? Okay, so we begin by learning the basic processor like 8085 or 8086, but make no mistake, none of this is outdated. I have written there 8085, 8086 till i9. So these two processors, 8085 and 8086, they are not outdated. Yes, your mobile phone or your computer today uses the most advanced cutting edge processors. If you are on iPhone, maybe A12 Bionic chip, or maybe if you are on Android, then other processors. But to run a traffic light, or to run even a TV remote control, you don't need a Core i7 now, right? So you won't be running an Android on your traffic light, or on your TV remote control, right? Or you won't be running an iOS on your TV remote control. So you don't need these processors, right? So you don't need an A12 Bionic chip in a small TV remote control. Fine. So and these are used by millions across the world. They simply use processors or the same grade as 8085 or an 8086 with different product numbers. They may not be the same product numbers, 8085 or 8086 plus, but the procedure, the instruction cycle, and all of the things remain same. So because see, these numbers they are made by different manufacturers. So they put their own code and they put their own patented things, but the basic process, with the basic procedure remains same. So don't ever feel that we are studying something which is outdated. They are definitely not. So that's all for this video. Hope you enjoyed the video, and we'll be continuing with the sessions in future video. So thank you.